Hello, Math Pirates. And today's Math Pirate adventure is on the Sea of Sequences. Yeah, I like that. The Sea of Sequences. Now, some sequences, they can just be random numbers, written in a row, separated by commas. And if they have dots at the end of it, it means that they're infinite. It means that they just keep on going. But some sequences have patterns. For example, these three sequences. All three of these have a certain pattern to them that once you know the secret code, you can go ahead and likely start predicting the next three or even further numbers that go in these sequences. And if we notice those dots at the end of them, that meant they were infinite sequences as well. Now, let's say one of those sequences, for example, instead of having the ... and here's a pretty straightforward sequence, but let's say it just has a dot and stops, then this would be a finite sequence. Did you find the pattern of sequence number 1? The square numbers pattern? Can you see what's happening in sequence 2 and sequence 3 in order to generate the next term? In sequence number 2, these were our terms. The first term, the second term, the third term, the fourth term, the fifth term, the sixth term. And notice how if I subtract, for example, the sixth term minus the fifth term, and then I take the term here minus the term before it, and I continue doing that, notice how they all came out to be 4. When this happens, you have found what's called a common difference. We're going to use the letter D to represent the common difference of an arithmetic sequence. Now, if you look at the third sequence, we have 7, 21, 63, 189, 567, 1701. Here, we have the first, second, third, fourth, fifth, sixth term as well. But instead, I take the sixth term and I divide it by the fifth term. And then I take the fifth term and I divided it by the fourth term. When we do this and we find a common quotient, we call this the common ratio. As a ratio, you might say 3 over 1. Ratio is a kind of another word for a fraction. So you can see how we made a fraction with a term divided by the term before it. And when it comes out to be the same value, we have a common ratio. And we use the letter R for that common ratio. Now, these types of sequences are called geometric. For the rest of this video, we're going to kind of pay attention to the arithmetic sequences. And then I'll make a second video about the geometric one. When we find a common difference, we have identified an arithmetic or arithmetic sequence. When we find a common ratio, we have identified a geometric sequence. So there's two things to put together: that common ratio with geometric, and common difference goes with arithmetic. When we discuss sequences, we like to talk about the terms, and you heard me mention those previously now in previous slides. Naturally, we call the first number the first term. And we say A with a subscript 1. 7 is the first term. We will call it A subscript 1. And we're going to say it equals 7. And instead of A subscript 1, usually we just say the first term, but we write it like this. We use the letter A because it's what we see in the beginning of arithmetic sequence. So A. continue with our terms, you can see we have the second term, the third term, the fourth term, and the fifth term. We may also write a table for a sequence. Notice how we use the term as where we usually put the x value, also known as the domain, and the term value in the y, which sometimes we use f of x if it's a function, and that is our range. Now this would give us a discrete table. And if you can think about some of your experiences, because math is experience-based, you know that once we have a table, we can also make a graph. So those are two ways that we can represent a sequence. Now we also write sequences using two types of formulas. One is called the recursive formula, and the other is called the explicit formula. The recursive formula used the common difference and the preceding term to find the next term. So if we are looking for, let's say, the 12th term, then we need the 11th term along with the common difference. So if you look at our arithmetic sequence, we have to go from 7 all the way to the 11th term. First, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th. And if we know that, well then we can add the common difference and get the 12th term. Notice the use of subscripts. And look at what we had to do in order to find the 12th term. Could you imagine if they asked to find the 1000th term? That would take us quite a while because we would need the 999th term, and then we'd have to add that to the common difference. So this is where mathematicians found what we would call the explicit formula. On this slide, though, in mathematics, we write a formula in general using variables. So we have the subscript 12, the subscript 11, and then we have the d for the common difference. So that would be a general formula for the 12th term of the arithmetic sequence that we're talking about. Now, in super general terms, notice how we use the n and the n minus 1 and the d here. And that would be like just the general, for all sequences, recursive formula. For our specific sequence, we would put in that common difference, which was the plus 4. As I was saying, we have also a special formula called the explicit formula because we do not need the preceding term. The explicit formula uses only the first term. Remember, that's the A1. It requires us to know which term we're looking for, or the term that we seek. And then we're going to have to take that number n minus 1 to use that in the formula. And then we also need the common difference. We would also need to know what the d is. If we know these 4 parts to the formula, well, then we can place those values in. So the general explicit for all sequences is a to the n, or the nth term, is going to equal the first term plus n minus 1 times the common difference. Now, some people like to use the commutative property, and they'll switch the 2 parts that are getting added together. And so they like to put the n minus 1 times d first, and then add the a. Do be careful that you multiply these first, and then add. We have to follow our order of operations. So let's go ahead and apply this formula. We have 7, 11, 15, 14, 23, 27. We all know the common difference is 4. We also can identify the first term is 7. We're looking for the 70th term, and 70 minus 1 is 69. We said that 4 was the common difference, and we said the first term was 7. So if we take this information and we enter it into our formula, there's n minus 1 times the common difference plus the first term. And we find that the 70th term is 283. Please watch the video again if you feel like you need more information. You can write this in notes, and rewriting sometimes help you understand it. And if you like, write some notes, put some questions, and then come and ask me, and I'll be happy to help you and give you other examples as well. Here to help you help yourself get better at understanding mathematics as a math pirate. And always remember, you can do the math. Thanks for listening. If you like this video, please like the video. And also, I'd like for you to leave a comment and let me know if it was helpful or if there's something I need to change. Thank you.